Hello, good morning once again. So I came across this question in the GATE 2008 Electronics and Communication Engineering subject. Question number was the 30 in the question paper, but the number may change. And I found this question very interesting because when I was preparing the solution for the previous year question paper of mathematics, so I found this one question and I solved it. Unfortunately or fortunately, the answer which I got was not in the options provided A, B, and C and D, none of them. So I rechecked my calculation and the question once again and again found that my question is correct but option is not matching. And in 2008, the paper came from the IC Bangalore. So doubting on the answer or the wrong question was very difficult. When I checked it thrice, more than 3 times, I checked on the internet and I found one interesting story. That at internet, there is only one solution to this question, which is being copy and pasted or being sold by the same method by each and every coaching institute. You find each and every book, and there is no discussion about this question at internet anywhere. But interestingly, this question was being sold by a wrong method to match the option. In the options, the option A option answer was 33, and there were other answer also, and I think this was the correct answer. And by solving this question by conceptually wrong method, this answer being matched, and at everywhere on the internet you will see the answer is the 33, but which is conceptually wrong. So why is it conceptually wrong? What is special in this question? The speciality is, the question is being said like this in the word problem: find the integration of 4x cube plus 10 y ki power 4 along the curve. There is no dx, there is no dy. Being dx means along the x-axis, being dy means along the y-axis. But it was being said, find the integration of this function along a straight line segment. And the equation of straight line segment is y, this c is y equals to 2x. Actually, it was not given y equals to 2x. There was given the 2 point, say 0, 0 and 1, 2. And by simply putting these 2 points, you can find out the equation of this line. This will come to be y equals to 2x. I'm not going to get. Okay. So you have to find this integration, not with respect to x, neither dx nor dy. You have to go along this path which is given by this y equals to 2x or along this line segment. Now let me first tell you what is being done everywhere. I'm sure many people have solved this question by themselves also, or have seen the solution, and you will see, if you will check wherever you want, you will find this solution only. What is being said? Along the curve, y is equals to 2x. So in this integration, you put y equals to 2x here. And if you put this y equals to 2x here, let it be 4x cube, let it be 10. So this integration which you need to find will be 4x cube plus 10 into 2x to the power 4, and then integrate it with respect to x. Integrate it with respect. I don't have any problem with this y equals to 2x if you put it, because along the curve y will be 2x. But putting is there dx is the conceptually a blunder. It's a blunder. And this is being done everywhere. Let me solve this question with this method, and when we are integrating it with respect to x, so limit of the x will be 0 to 1. So 0 to 1. So to save the recording time, let me stop it and give you the solution of this question, which anyhow you can do by simply solving it. Answer will come the 33, but let me give you the solution. So I'm pausing the video to save the time. So if you see, pause the video and check the solution. It is a simple integration of the class 11th or 12th, and you solve it and the answer will come to 33, which is matching in the option also, and that is why it is being very commonly used anywhere. But I had doubt in this dx, because this is not the integration along the x-axis. The integration is along this curve C. So what I did is, first let me tell you why this is wrong. I'm telling you this is wrong because of this, but let me verify you that this is wrong. If we have changed y equals to 2x there, and answer came this, if you say there is no problem in putting the dx, can we change into the y variable instead of all x here? Can we change instead of all y, putting x equals to y by 2? X equals to y by 2, this is already in y, total in y and all in y, and integrate it. And we will integrate with respect to y. So here will be dy, and the limit will be y equals to 0 to y equals to 2. So let me solve by that method also, and then check whether the answer is coming same or not. So again, for time saving purpose, in the side I will solve it with respect to y. I will put in this integration x equals to y by 2 here, and then limit of y, and will integrate with respect to y. And then let me see what answer comes. Okay. So in this integration, I put x equals to y by 2. X equals to y by 2. And this is in all y, single variable integration with respect to y, limit of y 0 to 2, 0 to 2. And this is the simple integration. You can do it by itself, or you can take a screenshot. And I solve it. You can also solve it. And the answer will come 66. It was the 33. It was the 66. In mathematics, there is no such constraint that you can only change into the x only. If you can change into the x, all variables into the x, you can change all variable into y also. And it is very clear. Let me give you the bigger picture. Okay. It is very clear. Solving with the x is giving 33, solving with y giving 60. It means there is something wrong in this question. In this solution, I'm sorry. There is some conceptual mistake in this question. And once again, what is that conceptual mistake? I am again repeating that this mistake is in putting this dx here or putting this dy here. Because dy means integrating with respect to y-axis or along the y-axis. So what is the correct method? Now I should come on to this. And that again, once you do the correct method, conceptually correct, then other mathematic juggling you can do very easily. There are again many methods to solve further this question. But once we are conceptually correct, it doesn't matter what method we use further, we will be okay. So what is the correct method? So the problem was that we are asked to find the integration along a curve C. And there is some function which is given, say 4x cube plus 10 y to the power 4. Along this curve, there is no dx, no dy. There is a curve C from 0, 0 to 1, 2, which is y equals to 2x. And when we find an integration along a curve, so if you remember in the calculus, we say this, we need to find, if you have gone through this GATE mathematics, you definitely will have gone through the finding the length of the curve, which used to come like S. And we had the formulas to calculate the length of the curve, say ds. And ds equals to something like this, 1 plus dy by dx square. This was ds by dx, like this. If you have not seen this earlier, I hope you must have seen, because many questions are being asked related to this in the GATE already. So my point is that you need to integrate this curve not along the dx, not along the dy, but along the ds, along the ds. And this is a function. So this function, say gxy, the function in the two variable, is being integrated with respect to ds. Now it is your choice. Either you make it ds by dx or you make it ds by dy. If you make it ds by dx, then put here also dx. Multiply and divide by dx, there is no change. Okay. So once you put this value there, ds by dx or ds by dy, if you put ds by dy, then this will become 1 plus dy by dx by dy ka whole square. This will be turned out. Okay. Then you can integrate it with respect to x. So that in earlier methods, direct dx was there. This term was being conceptually not being there. But now what is ds? Okay. See, this was the y equals to 2x. So what will be dy by dx? It will be 2. It will be 2. Okay. dy by dx will be 2. So ds by dx क्या होगा? 1 plus 2 का whole square. 2 square 4 plus 1, that will be square root of 5. So here you need to put the square root of 5. And the other question is the same. And square root of 5 is a constant term, so that can be taken out. So square root of 5. And then integrate you. Then you can integrate gxy. And y equals to 2x you want to put, you can put. And into the dx. And now you can put the x ki limit of x from 0 to 1. Okay. Or you find ds by dy and integrate with respect to y. And this part is already being solved previously in this way. This is the function. Put the y equals to 2x and integrate it with respect to x from the limit 0 to 1. The same is here. So this will come 33 as usual. And the constant term root 5 was already there. So into root 5. So that must be the answer. That should be the answer. 33 into root 5. But this is none is not in the options. This is not in any option. And since this is not any option, so people made this method correct. Okay, that time it was in the option, but it was conceptually incorrect. The question must have been challenged, or if not challenged, then that time it's okay, but you should now be conceptually correct. That is my point. That's why I'm making the special video for this question. I was preparing the solution. I came across this question. I found this question important or necessary to discuss with whoever is watching this video. Maybe one people, 2 or 3. Okay. You can try this question by dx by dy also. Let me do it. So if you want to solve it in with respect to ds upon dy into dy, so you need to find ds by dy, which is this much. Y equals to 2x, x equals to y by 2, and you will solve and put value. This will come root 5 by 2, and you integrate. Now here you need to change x into the y. Here you change y equals to 2x, x as it is. Here you need to change x equals to y by 2, y as it is. Means in terms of all y and different integrate with respect to y. Okay. So again, this is we already solved. Answer was the 66 in the previous question. We solved this. So there will be root 5 by 2 into 66 to 33 square root of 5. The answer must came the same. Doesn't matter you change into the x or y if you are conceptually correct. So that method is incorrect. And this method is correct. We change into the all y variable and integrating it with respect to y. Answer the same. We change into all x and it solved it with respect to x. Answer is the same. Means, or there are many other method also you can, again, that is the mathematical juggling you can do in any way. Suppose if you change into the parametric form like x equals to t, so here y equals to is 2x, so y will be 2t, and in that case ds by dt will be dx by dt whole square plus dy by dt whole square. Dx by dt will be 1, so square will be 1. Dy by dt will be 2, 2 whole square is 4, so it will again come root 5. So in that case also we will change the integration in g x equals to t, y equals to 2t into ds by dt. ds by dt is again is coming root 5, so there will be root 5 into dt, and the t will change from 0 to 1. Again this integration is being done here also. It will come 33 into root 5, so again answer will come the same, 33 into root 5. So it doesn't matter you solve it with respect to x, with respect to y, or in a parametric form, or do you want to solve in any other form, the answer will always be the same because you are conceptually correct. I would say this method is incorrect partially. Putting the value is not a problem, but this is the problem. And this concept, whoever solved this question first in this by this method and matched the answer, and then all solve in this method, because this kind of questions generally we read or see in the complex variable. But again, the point to be remembered is there we never put only the dx or only the dy. There come dx plus iota dy. What is that? I should not discuss this here, but just for a brief, there come dx into dy. So we integrate with respect to neither dx nor dy, dx plus iota dy. And when we change into the function, suppose we changed y equals to 2x, so we change dy equals to 2 times dx also. So this dx plus iota 2 times dx. So dx into 1 plus 2 iota. So there also we never put only the dx. In function we change y equals to 2x, that's okay. But when integrating we do not put direct dx. We change the dy also, and that comes like this. There is some factor which is coming root 5 in our bed. That was from the point of view of the basic engineering mathematics. But again,